In this lecture, we're going to see how we can declare and use our lambda functions. And again, lambda functions are a mechanism we have in C++ to set up anonymous functions. And an anonymous function is a function without a name. We're going to see how we can set up an anonymous function, optionally give it a name and call it, or we can even call it directly without giving that a name. Let's see how we can do that. Before we talk about anything about lambda functions, we're going to first see the lambda function signature. And there is a special syntax you have to follow if you want to set up a lambda function in C++. The first thing you have to put in place is angle brackets like this. And that's going to be your capture list. We are not going to talk any more about this. We're going to have a chance to talk about this in detail. After your capture list, which is going to live in this pair of angle brackets, you're going to have the parameters to your lambda functions. And this is where you can pass arguments if you want to call your lambda function. After that, you're going to have a return type for your lambda function, but you don't have to put this in explicitly. You can leave this out and the compiler is going to deduce your return type by itself. After all these things, you have to put in a pair of curly braces, and inside these curly braces, we're going to have our function body, and we can do whatever we want our lambda function to do in this function body here. After this, you will have to remember to put your semicolon to make whatever statements contain this lambda function to be valid, and this is the syntax you have to follow. Here we have a simple example. So we have our lambda function. We want to say hello to the console. This is what we have in the body of the lambda function. But notice that we have our capture list, which is going to be delimited by these angle brackets. We have our parameter list, which is going to be empty in this moment because this lambda function doesn't take any parameter. And we have our body, which is going to live within these two curly braces. And after that, we have our semicolon to make this a valid C++ statement. If we try and put this thing in our C++ source code, this is going to be a valid lambda function. But it isn't really useful by now because we can't call it. One way we have to call it is to give it a name. And we can give it a name by assigning our lambda function to a variable like we see here. Once we have our lambda function declared like this entire thing is going to be our lambda function type. We can take this and assign that to a variable which is going to deduce the type using auto type deduction here. This is what we are doing. Once this thing has a name, then we can call it with the syntax we have here. And if we run this code now, it is going to print hello world to the console. I realize this syntax can be really cryptic, but if you try to remember this, you're going to find that lambda functions are really cool. And later in the course, we will see that they really make a lot of things easier in C++. So try to remember the syntax here, and everything is going to flow from here. Again, the syntax is to have the capture list, which is going to be the first thing. The second thing is going to be the parameters. The third thing is going to be the return type, which is optional. You can leave this out and the compiler is going to deduce this. And after this, you're going to have your pair of curly braces, and the body of our lambda function is going to live within these curly braces. This is the syntax you need to remember. Okay, we have seen that we can give a name to our lambda function and call it, but it is also possible to call our lambda function directly without giving it a name. And we do that by appending a pair of curly braces to the lambda function definition here. So we have a lambda function, we have our curly braces in, we have our parameter list, we have our body here, and after the closing curly brace, we're going to add a pair of parentheses to call this lambda function. And because this lambda function takes no parameter, we're not going to put any argument within our parentheses here, and this is going to call our lambda function. Don't worry if you find this confusing. We're going to head over to Visual Studio Code in a minute, and all of this is going to make sense. Okay, so far we haven't really seen that we can pass parameters to our lambda function. Here is a simple example that takes parameters. This is a lambda function because it follows the syntax for lambda functions. We have our capture list, we have our parameter list, we have our curly braces, and the body is going to live inside these guys. and we are calling this lambda function directly with this parameter list. The lambda function is going to take two parameters of double type. We're going to print out the sum of these two numbers, and we are going to call this lambda function directly. Notice that we are passing in our arguments as double literals. Okay, this is how you can set up a lambda function that takes parameters and call it directly. Another thing we can do is make our lambda function return something. And that's really simple. We're going to set up the lambda function like this. So it's going to take two parameters, a and b. And here you see that we are returning a plus b. And we can do that. The lambda function is now going to return something. And this entire thing we have here is going to be a lambda expression. The lambda function is going to be called, it is going to return something, and what the lambda function returns is going to be assigned to this result variable here. And if we print it, we're going to get the sum of whatever we pass in here printed out on the console, and we're going to see it printed out on the terminal. It is also possible to put your lambda function directly in an output statement. I realize this can be really confusing, but please look at this entire lambda function thing here as a single value. Because this is a lambda function that is going to return something, and what is returned by this lambda function is going to be printed as our result here. Again, I realize this may be confusing to many of you guys. We are going to head over to Visual Studio Code in a minute, and we're going to see this, and you're going to really understand. Okay, the last thing we're going to look at is that we can specify a return type to our lambda function. And the syntax to do this is to do a dash, a greater than symbol, and put your type after that. And when you do that, now this lambda function is going to be forced to return double type. Even if you pass it to parameters that are not of double type, we are going to add them up, and the return type is going to be implicitly converted to double, and that's what we're going to return, and we can print it out on the console. And we're going to see an example of this in a minute when we hit Visual Studio Code. In fact, this is really all I had to share with you in the slides. I realize many of these things may be confusing. We are going to head over to Visual Studio Code and play with these things step by step, and I am sure you're going to understand. Here we are in our working directory. The current project is declaring and using lambda functions. We're going to grab our template files and put them in place. Let's do that. And we're going to grab our folder here and drag and drop it in Visual Studio Code. And this is going to open it. It is opened here. We have our main CPP file opened. We can close the left pane here because we don't want it anymore. And we can clean up our function here. And the first thing we're going to do is to put in the syntax for a lambda function here and use it as a reference as we learn about this. I think this is going to make things a little easier. So the first thing we want to do is to declare a lambda function. And the first thing we need to put in is a capture list. A capture list is going to be englobed in these angle brackets. So this is our empty capture list. And after this, we're going to put in a parameter list, which is going to live inside these parentheses here. After that, we're going to put in an optional return type. For now, we're going to ignore this. And after that, we're going to put in our pair of curly braces. And inside this pair of curly braces is where the body of our lambda function is going to live. So inside here, we can do whatever we want in the body of this lambda function. For example, we can say hello world, which is the logical thing to do at this point. So we're going to say hello world here, and we're going to put in our new line character with ENDL. Okay, now we have a lambda function declared, but we have to put in a closing semicolon because this is a C++ statement. Okay, now we have our lambda function declared, and this is valid C++ code. If we try to compile this program, you're going to see that it is going to compile fine. Okay, build finished successfully. And if we try to run it, it is not going to do a thing because we are declaring the lambda function here, but we're not calling it to get it to do things. So let's bring up a terminal and show you that if we run this program, it is not going to do anything. So let's do clear and run rooster. You're going to see that it's not going to print anything. And we can even go down here and put in a closing stdc out statement saying done to mean that we are hitting the end of the function here without doing anything. So if we build again, the build is going to be good. We can clear and we're going to run rooster. You see, we are printing done. We are hitting the end of the function here, and we're not seeing hello world. So this function here, or this lambda function here to be exact, is not being called. One way we have to call it is to give it a name. And we have seen that to give it a name, we have to assign the entire lambda function thing we have here to a variable. And we're going to use auto-type deduction here. So we're going to say autofunc, and we're going to assign our lambda function here to this variable. And this is going to be basically a handle we have in our program here to the lambda function. And we can use this handle to do things with the lambda function. But by now, I want you to see that even if we run the program now, it is not going to do anything because we're still not calling the lambda function here. Let's show you that we're going to build again, and the build is going to be good, no problem. We can clear and run rooster. Still no hello world because we're not calling our lambda function. To call our lambda function, we have to use our handle here, which is this variable, and use regular function called syntax. So we can go down here and say func, and we can put in our parentheses. We're not putting in any parameter because this lambda here doesn't take any parameters. And now, if we run this program, it is going to say hello world because this line here is going to call this lambda function. Let's build and see that. We're going to use GCC to build. So now, if we clear and run rooster, we're going to see hello world. We can call this function multiple times because we have a handle to it. The handle is going to be valid throughout the scope of the main function here. So we're going to go down and call it again. And if we build, we're going to build with GCC. The build is good. We can clear and run rooster. We're going to say hello world twice because we are calling our lambda function twice. This is one way we have to call our lambda function here. So we're going to comment this out because we're going to see a few other things. And on top here, what we were doing is declaring a lambda function and call it through an A. Now we're going to go down, set up a lambda function and call it directly without giving it a name, because that's also a possibility in C++. For that, we're going to grab our lambda function here and we're going to copy it. And we're going to say declare a lambda function and call it directly. And the syntax to do that is really simple. You set up your lambda function like we have seen before. You see, this is our lambda function statement here. But you're going to go to the closing curly brace and add a pair of parentheses. This is going to declare the lambda function and call it directly. Notice that we don't have a handle to this lambda function. So if you do things like this, you will have only one chance to call the lambda function. So we're going to say hello world once because we are declaring the lambda function and calling it directly here. And after that, we're going to say done because we're going to be hitting the end of the main function here. Let's build the program and show you that. We're going to build with GCC like we always do. We're going to clear and run rooster. This is going to say hello world. And we're going to be done here because we are calling this lambda function once. Again, notice that now we don't have a handle to this lambda function, so we really have one chance to call this. And you will do this if you just want to set up some function that you want to call directly and you don't care about calling it ever again in your C++ application. And we're going to see that we have many kinds of problems where we want to do these kinds of things. Okay, now that you have seen this, the next thing I want to show you is how to set up a lambda function that takes parameters. And we're going to comment out what we have on top here because we don't want noise output on our terminal. And we're going to grab this lambda function and adapt it. So let's copy it. We're going to go down here and put it in. And we want to pass two parameters now. Let's pass in double parameters. We're going to pass in double A and double B. We can do that. And inside the lambda function, we can print the sum of these two variables. So we're going to say a plus b, for example, and we're going to print out whatever is the result of a plus b. Let's do that. And after we do that, you're going to see that we get a compiler error because now our lambda function is taking parameters, but we are calling that with an empty list of parameters. So we need to give it something to sum up. Let's give it 10.0, for example, and 5.0 and see what we get. And after this, we need to put in our semicolon because this is a C++ statement, and any C++ statement needs to end with a semicolon. Now, try to think about what we are doing here. We are setting up a lambda function. Okay, it's going to end at this closing curly brace. And this lambda function is going to take two parameters of double type. And inside the lambda function, we are going to print out whatever is the sum of these two parameters that we are taking in here. After that, we are calling our lambda function with two variables, 10.0 and 5.0. Or I should say two double literals. That's what we are calling our lambda function with. And now, if the program runs, the lambda function is going to be called once, and we're going to print out whatever is the sum of these two numbers, and that's going to be 15. Let's build. So we're going to build with GCC. The build is good. We can clear and run rooster. We're going to see a plus b is 15. We are calling our lambda function here. If we put in a 50 here, for example, we're going to get 60 printed out because that's going to be our sum. Okay, let's build again and see that printed out. If we run rooster, we're going to see 60 because that's the sum of 10 and 50 here. Another thing we can do is actually not call the lambda function directly here. We can actually comment this out. I don't want to take this out because you might want to use this as a reference. So we're going to comment this out and set up another example that is going to name our lambda function, and then we will have a handle to the lambda function and we can call it multiple times. So let's take out the call we are doing here, and we're going to assign our lambda function to a variable. We're going to say auto func1. We can call this func1, no problem. And now we can call this lambda function multiple times. For example, we can say func1 and pass in 10 and 20. Okay, and we can say func1 and pass in 5 and 7. Why not? If we run this program, it is going to print the sum of 10 and 20, and it is going to print the sum of 5 and 7. And it is going to be calling this lambda function multiple times. Hopefully you can see that if you want a chance to call your lambda function multiple times, you will need to give it a handle like we are doing here. And then you can use that handle multiple times and call your lambda function however many times you want. So let's build this program and see what we get on the console. We're going to clear and run rooster. Now we're going to see a plus b is 30 as a result of this call here, and we're going to see a plus b is 12 as a result of this call here. Notice that we are passing in integer literals. So the compiler is going to insert an implicit conversion from int to double because our lambda function here is taking double type. You really need to be aware of these implicit conversions and make sure they are working to your advantage. If they are working against you, try to find a way to make your code work exactly like you want. Because we are learning about all these cool tricks in C++, you're going to be using them at your advantage. Okay, hopefully now you know how you can set up a lambda function that takes parameters. We're going to go down and comment this out because now we want to see how we can return something from a lambda function. And we're going to be using the same lambda function here. So let's grab it. And we're going to say lambda function that returns something. And we're going to set up our lambda function here. Let's put that in place correctly. And instead of printing out the sum of a and b, we can return that. We can go in our lambda function and say return a plus b. Okay, now that we have this, we can either call it directly by saying, for example, 10 and 20. But now, if we try and run this code, it is not going to do anything. Try to guess why. This lambda function is not printing to the console directly. It is just returning whatever is the sum of 10 and 20. And if we return it, we're not doing anything with whatever is returned from this lambda function. So we're not going to print anything, and we're just going to print down here. Let's build and make you see this, because you really need to be aware of these little things. So the build is good. We can clear and run rooster. We're going to see done. Our lambda function is returning something, but we're not doing anything with the return value. If we want to print the return value, we need to catch it somehow. And we can put that in a variable, for example. We can say auto result and assign the return value of our lambda function to this variable. Now we have a chance to print this, for example, by doing stdc out result, and we're going to print that out and say result. Now if we build this program, it is going to print whatever is the sum of 10 and 20. Let's do that and show you that this is actually the case. So if build is good, so we can clear and run rooster. Result is 30. If we pass in 10 and 50, for example, we're going to get the same thing. Let's pass in 60 here. So we're going to build with GCC. The build is good. We can clear pretty quick and run rooster. Now the sum is 70, and this is how you can return stuff from your lambda function. And once you return stuff, you have to be sure you catch your results and print them out. Another thing you can do is print out the result directly after you call your lambda function. So for example, we can grab this entire lambda function thing here and put that in an stdc out statement. So we're going to put in a second one here and say result, or we can even comment this out. We don't want to be confused when we look at the terminal here. We're going to comment out the first stdc out statement here, and we're going to say stdendl here and put in a placeholder for our lambda function, and we're going to paste it in. If we do something like this, again, this entire lambda function thing is going to return the sum, and that's what we're going to print. I realize this syntax is really cryptic, but it is going to work. Let's try and build our program here. The build is good, so we can clear and run rooster. We're going to see that result is 70, and this is coming from our call here, which is nested inside our stdc out statement. You can do this if you want. Another thing you can do, as we have seen before, is give your lambda function a name and call it repeatedly. So for example, we can try and comment out what we have here and set up another lambda function because we don't want to confuse you again. So we're going to grab our lambda function here. We're going to copy it because we don't want to type this 1,000 times. And we don't want to call this lambda function directly. Instead, we want to give it a name, and we're going to say auto func2, and we're going to assign our lambda function type to func1. Now that we have this, we can say auto result1, for example, and we can say func, and we can pass in whatever we want. Let's put in 23 and a 7, and this is going to add up 23 and 7. We're going to grab the result, and we're going to assign that to result1. If we go down and say auto, for example, result2, and say, for example, func1, and say 9 and 45, why not? And go down and print out these result variables. We're going to see the sums printed out. And again, the message is that we can use this handle to call our lambda function multiple times. So let's go down and print these out. We're going to say result1, and we're going to say result1 here. We're going to go down and say result2, and we're going to print that out. And we can even call this lambda function directly and put that in stdc out here. So let's say that we're going to say result3, for example, or direct call. I think this is descriptive enough. So we're going to say func1, the name of our lambda function, or the handle to the lambda function, and we can put in a 5 and a 2, for example, and we're going to see this print out the result. If we build our program, let's do that with GCC. The build is going to be good. We can clear and run rooster. We're going to have result1 is 30, which is 23 and 7, so the sum is 30. The second one should say 54 because that's the sum, and the third one should say 7 because that's the sum of 5 and 2, and it is what we have here. And after that, we're going to see that our program is done. This is how you can set up a lambda function that returns something, and we have seen many ways we can work with this. Let's comment this out because there is one more thing I want you to see, and that's a lambda function whose return type is specified explicitly. Okay, we are going to reuse the same lambda function we have been using all along, and we're going to copy that. And we're going to go down and put it down here. And now we want to specify the return type as double. The way we do that, we go after our parameter list and we put in a dash symbol and we put in a greater than symbol. And then we're going to specify the return type of our lambda function. Let's say that we want our return type to be int. This is how we say it. Now our function here is going to return int regardless of the types that we put in. So what the compiler is going to do when we call this lambda function, it is going to take the parameters, it is going to add them up. For example, now they are double. So it's going to add a and b as double. It's going to produce a double variable. Then it is going to convert that to int and return it. You notice that now we have forced our lambda function to really return a specific type here. Before, the return type was deduced from the operation that we did here. And before we were returning double because that's what the compiler was deducing for a and b here. To really drive the point home, let's assign this lambda function to func1 or func3. Let's do that. We're going to say func3. And this is a lambda function that is going to explicitly return int. And we're going to set up another one which is going to deduce the return type. We're not going to specify the return type explicitly. So we're going to take out our return type here. Let's do that. And we're going to go down and say auto result3, and we're going to say func3 and add up two double variables. Let's set up these variables explicitly so that you really see what is happening. So we're going to say int a and put in a 6.9, why not? And let's make this guy a double because that's what our function here expects. And we're going to do another one, do double b, and we're going to put in a 3.5, for example. And we are going to use these variables as arguments here. We're going to say a and b, and we're going to say auto result 4. This should be func4, sorry for this. And we're going to say result 4, and this should say result. I am making many typos. So we're going to assign our lambda function, the result of our lambda function, I should say, to result 4 here. And we're going to pass in a and b. Now, we want to see the types of result 3 and result 4 here. We're going to go down and print them out. We're going to say stdc out size of. This is one way we have to get the types of our variables. We're going to pass in result 3. We're going to say size of result 3, and we're going to go down and say size of result 4. Okay, we have our code in place, and what we want to see is the type that is deduced by the func3 lambda function here. We are explicitly turning the return type into int. The parameters we pass in are going to be double. That's what we have here. We are going to add up a and b, and the result of this is also going to be double. But the compiler is going to notice that we are returning int explicitly here, and it is going to take this double result and transform that to int. And we're going to get the result of that assigned to func3 here. For the second lambda function here, we are going to automatically deduce the return type. So what we return here is going to be a double type. And we should see a size of int for result 3 here printed out. So we should see a 4 on my system. And for the second statement here, we should see a size of double printed out. This is one way we have to try and prove this. So let's build this program and see what we get. Okay, the build is good. We can clear and run rooster. And we're going to see that this is exactly what we expect here. If we want, we can even print result 3 and result 4 and see what we get. So let's do that. We are learning. So let's experiment with this a little bit. We're going to say result 3, and we should go back and say result 3, if I can type ENDL here. And we're going to go down and say stdc out result 4. Okay, if we build and run this, we're going to see the results printed down. The build is good. We can clear and run rooster. Now we have result is 10 for the first thing here, for the first lambda function, and for the second one, result is 10.4. You can see that for the first one, the result was transformed from double to int, and for the second one, we deduced double, so we still have our decimal point here. Hopefully, this makes sense. And this is really all we set out to do in this lecture, showing you different ways you can set up your lambda functions. We saw the syntax of setting up a lambda function. We saw that you can declare a lambda function and call it through a name like func here. We went down and saw that you can declare a lambda function and call it directly through the syntax you see here. We saw that how we could specify parameters to our lambda function. This is the syntax. And once you do this, you have to remember to call your lambda functions with parameters like we see here. We can even use a handle given to our lambda function and call our lambda function multiple times. After that, we saw that we could return something from a lambda function, and we had many chances to play with us. And we finished by looking how we could specify the return type explicitly, and the syntax to do that is what you see here. We are going to stop here in this lecture. In the next one, we're going to see how we can use our capture lists here and make them do useful things. Go ahead and finish up here and meet me there.